Hi, hello students. Let's start our discussion regarding the chemical kinetics only. Students, one point remember that when you are remember the chemical kinetics, because the name itself is the chemical kinetics. What mean kinetics? You remember you can see the two diagrams are there. One is the some Tata is the rabbit will be there, which will move fastly. The very rabbit will. So in this chapter, I'm discussing about the speed, rate, velocity of a chemical reactions only. In the chapter, I'm going to discuss about the speed, rate, velocity of chemical reactions only. Some students ask, sir, why are chemical kinetics benefits are there? Students, wherever is there, when you remember here, one more point I want to say very clearly. When you purchase any milk packet is there. Their mention is there, no, after particular days is there, no, the milk becomes spoiled. Expire date will be there. Similar way, when you purchase any food items are there, they mention on expire date will be there. And also when you are riding any vehicle is there, they mention is there, this vehicle will give the up to this much kilometer. If you suppose if I use 1 liter of petrol, this many kilometers will give only. And also whenever the satellite they launches the satellite, they will say after few days is the satellite will be go particular orbit or whatever maybe is. Next one is the flight will be moved from India to some other countries within this time is there. How they are measuring this time? Chemical kinetics. Chemical kinetics is a branch of science which deals about the speed, rate, velocity of a chemical reactions only. So first one point remember is there what is chemical kinetics? Kinetics means momentum only. Kinetics means momentum only. A branch of science that deals with the rate of reaction, mechanism of reaction, and factors affecting reactions only. So in this chemical kinetics, I am going to discuss about the rate, speed, velocity of a chemical reaction, mechanism of a chemical reaction. What is mechanism? How the molecules are reacting, how they are breaking the bonds, how much amount of activation energy required. So we are going to discuss in the chemical kinetics. Not only that one is in a chemical in this chapter, I am going to more focus about the factors influence the chemical reactions. What are the factors? Do you know wherever is there some chemical reactions are without catalyst they occur themselves. Some chemical reactions are require catalyst only. Some chemical reaction occur at highest temperature, some chemical reaction occur lower temperature. So what are the factors will influence a particular chemical reaction? We'll discuss in this chapter only. So remember one more point is here, the one basic idea is there here. Right now I'm discussing about the more problem is COVID problem only. So everybody facing about the COVID problem. So any industry which can produce the COVID vaccine with a cheap rate immediately, that is the most successful only. So how they are saying they will say mention is there COVID vaccine will come for 2 days only. When it particular time is there here, let's say chemical kinetics only. Okay, chemical. Actually, one more point I want to say very clearly, any industry want to produce any product low cost, with low cost and easiest method only. When you found that any medicine is a low cost easiest product is called as more successful product only. So most of the industries are very fascinated about the chemical kinetics only. They want to study about chemical reaction. They want to make a chemical reaction in chemical process with easiest method and cheapest method. So in this chemical kinetics, we are discussing about the collision theory. What is collision theory? Whenever the atoms are collide each other, they will exchange energy, they become a product only. So collision theory, according to collision theory is there here last year, but this academic year is not there. So students, we are discussing about more in detail about the chemical kinetics only. Chemical kinetics deals with the speed, velocity, rate of a chemical reactions only. In order to complete a chemical reaction, how much time is required? How the concentration will be varies with the time to time is discussing about the chemical kinetics only. So remember in this case consider some chemical reactions are there. So they have given one flow chart is there. Remember consider we discussing about the chemical kinetics, we discussing about the speed, rate, velocity of a chemical reaction. Sorry. How much speed a chemical reaction occur. Okay, the next one is the feasibility of chemical reaction, whether the chemical reaction occur or not, explain about the thermodynamics chapter. Thermodynamics chapter, according to thermodynamics, whenever delta G value is negative, then the chemical reaction occur. Whenever delta G value is positive, the chemical reaction will not occur easily only. Next one is the chemical equilibrium chapter, which deals about the how much extent of product is formed only. How much of extent of product is formed, discuss about the chemical equilibrium only. But in this chapter, I'm focusing about the speed of a chemical reaction. So speed up to whatever discuss about the first with standard chemical balance, chemical equation discuss, 11 standard oxidation reaction discuss. In this one is thermodynamics study and chemical equilibrium study. But we never ever focus about the speed of a chemical reaction. Okay, speed up. Remember, you just consider when you saw this vehicle is how much vehicle speed. how can speed distance covered within time only. Change in distance by time is called chemical distance speed only. Here kinetics also speed only. What kinetics is about change in the concentration of reactant per unit time only. With respect to time, how the changing of concentration of reactant is occur only. So based on this one is then the chemical reaction has been classified 3 types. Is there very fast reactions, slow reactions, moderate reactions only. So remember here just consider the whenever you see the kinetics means remember car, speed of the car. Speed, how can you say? Distance covered within time only. Next one is then here in this chemical kinetics, the chemical reactions I will discuss about the. Look, you can see very clear here the very slow reactions, fast reactions are there. Slow reaction, fast reactions. So what happens you can see very clearly that the ripening of fruits are there in a slow process only. Ripening of fruits is slow process only. Next one is that here is considered the burning of mastic is a very fast process only. Burning of mastic is very fast only. Fast reactions occur only. So in our chemical kinetics, we are more focusing about the moderate chemical reactions. We are not more focusing about the slow reactions or even very fast reactions only. So next one is one more slide, we get very clear idea. We can see very clearly whenever silver nitrate add the sodium chloride, when I add small amount of silver into sodium chloride, immediately white color precipitate is formed. So what I mean, this reaction happens within a fraction of seconds. So I cannot measure the speed of this chemical reaction with the blinking of eyes. This chemical reaction occurs. It's a very fast reaction. Chemical kinetics never discuss about the very fast reactions. It always concentration about the moderate speed of chemical reactions. And also you can see very clearly there is nothing but rusting of iron only. Rusting process. Rusting is an undesirable process only. So what I mean, whenever iron react with oxygen, they form in the presence of moisture, they form a ferric oxide. You can see nothing but rusting of iron. But when the rusting maybe takes place, 6 months time will come, 3 months, 4 months, whatever maybe there no huge time is required. So chemical kinetics never discuss about the slow chemical reaction. It always focuses about the moderate chemical reactions only. So next one is remember here the silver nitrate plus sodium chloride is a form of silver chloride plus sodium nitrate. It's a very high speed of chemical reaction. Next rusting of iron is slow chemical reactions only. So next one is ester hydrolysis. Ester molecule. Whenever you saw this kind of structural formula, ester. Whenever ester hydrolysis, it gives acetic acid alcohol. This ester hydrolysis takes place in terms of acidic medium. So this kind of reaction is called moderate reaction. So chemical kinetics deals about the moderate speed of a chemical reactions. Moderate speed of a chemical reactions only. So remember here the next one is some moderate speed of chemical reactions already mentioned very clearly. Decomposition of hydrogen peroxide. Hydrogen peroxide decompose, they form a water molecule and oxygen is there. No, it occurs at a moderate speed only. So we are focusing about the decomposition of hydrogen peroxide. Decomposition. Next one is the inversion of cane sugar only. What inversion of cane sugar? Sugar molecules breaks into glucose and fructose. Sugar molecules breaks into glucose and fructose called inversion of sugar only. So what happens? This chemical reaction also moderate speed of chemical reactions only. It's not occur very fast. So next one is then so chemical kinetics deals about the ester hydrolysis only. So should you remember this in this chemical reaction is then we discuss this called pseudo order chemical reactions only. Again, pseudo order. Why I mentioned pseudo order we'll discuss later only. Next one is the decomposition of dinitrous pentoxide. Already mentioned is there in the last itself is there nitrogen pentoxide decompose, they form a nitrogen dioxide plus water. So what happens this reaction occurs moderate speed only. So from this one we got very clear idea. In this chapter I am going to more focus about the moderate speed of a chemical reactions. I am not concentrated about the very fast reaction. I am not concentrated about the very slow reactions. So in this chapter they are focusing about the moderate chemical reaction, how factors influence the moderate chemical reaction, either the reaction become very fast, either the reaction become very slow. So this is about a chemical kinetics only. So next one is that remember the rate of reaction and units only. Rate, what is rate here? Change in the concentration per unit. So for every rate, what happens there? Some units are there, no? So that's called rate units only. So what is units are there here? Just imagine the reactant R is converted to product only. Whenever reactant is converted to product, what happens there may be change in the concentration of reactant. Change in the concentration reaction. Change in the concentration, what happens? The rate only, no? Rate also called speed only. What you call speed is the change in the position per unit time. What you can say the speed is the change in the position per unit time only. So speed only. So similarly, what happens is similarly the chemical reaction is there here. Rate nothing but change in the concentration of reactant or product with respect time only. What is written at the change in the concentration of reactant or product with respect time only. So what happens with time leads on the reactant concentration decreases, the product concentration is increases only. Okay, now whenever times goes out on the reactant concentration decreases, product concentration increases only. So whenever reactant concentration decreases, the minus sign will come, product concentration increases, the plus sign will come only. So this one on right on. Next one is then here some units are there. So what is concentration per time they have taken? What is the concentration units are there now? Moles per liter only. Rate of reaction change in the concentration per unit time. What is rate of reaction at the change in the concentration per unit time with respect to unit time, how change in the concentration is there. So you know very well what is units for rate in the change in the concentration per unit time. What is concentration units are the moles per liter. What is units concentration? Moles per liter. What time? Seconds only. So what will get the moles per liter per second. Sometimes what happens in the time I will take the second, minutes, years also is there. So what happens the moles per liter inverse, minute inverse. Okay, in the form of liters I am taking decimeter cube. That's not wrong, no. Moles, decimeter cube inverse, cube. Next one is the minutes inverse one. So what happened there? This is a very important, students. The concentration of the change in the units of the rate is change in the concentration per unit time. Concentration of the moles per liter. Time is seconds only. Minutes also can take only. So next one is that here based on the units we are going to calculate the rate of chemical reactions only. Different units are there, different rate will come only. And one next one is then a graphical representation. Students, a lot of students they have some confusion is there now. Here we are using one graphical representation of chemical reaction. Here we are using everything is graphical representation. We know very well now chemical reaction I cannot see, but I can see the chemical reaction speed velocity by using the graph only. So here we are using the graph is called y is equal to mx plus c, straight line equations only. So the graph, everything is important graph only. Look at this one graphical representation of chemical reaction I have taken here. Then now look at this as product concentration with respect to time. What happened there? I said very clearly the product concentration is increased with respect to time. What happened? What the particular point become constant only. And also you can see what happened there, positive sign is a positive value only. When you come to reactant, what happened there? Reactant concentration always decreases with respect to time only. What happens slowly reactant the current product only. So when now this both reactions, so when I put in single chemical reaction is there now concentration over time, product concentration is increases, reactant concentration is decreases only. Reactant concentration decreases only. So that's the reason why here the next one is that here representative rate of chemical reaction. Do you know very well any whatever the chemical equation is then I have to represent by using certain methods are there. That's called representation of a rate of a chemical reactions only. So in this one you can remember here this one is considered the R1 is reactant. Okay, just consider the R1 is the initial reaction, initial reactant concentration, R2 nothing but final only. What when the time, initial time and final time is. So I want change the liquid. Suppose just imagine here the and just mention is here particular reactant concentration changes from the from 10 let's consider the 10 molar concentration to 5 molar concentration is there. Initially is 0 time to 5 minutes is there. So what happens? I want to measure the how much change in the concentration. Change in concentration at the delta R. What is final minus initial only? Final minus initial only. Change in time, what happens there is delta T. T2 minus T1 only. Students are here, notations are very important. Delta T stands for the whenever you measure the change in the time at larger intervals only. That's called T2 minus delta value. Small d nothing but small intervals of time only. Capital R stands for nothing but a large change in the concentration only. Large change in the concentration. You know, next one is the rate of reaction is there no decrease in the concentration R by time taken only. How can that rate is there no change in concentration dr by dt only I mentioned. What is the rate nothing but a change in the concentration with respect to time only. With respect to time how the change in the concentration will be takes place only. The next one is here the one more thing is remember here. Here one more is there now. Look at this now. Sometimes I will take the pressure also. Pressure also is there. You can remember the concentration units we will take as a in the concentration taken as a C also. We can take pressure also in there. So what happened there is the initial pressure is there now. Here consider the P1 changes to P2 only. Time is T1 changes to T2 only. What happened there? Consider the reactant convertant product. Just because here taking the reactants convertant product only. So what happened there here just measure here the rate I'm mentioning this in this equation with respect to reactant only. I want measure the rate with respect to product also. I want measure rate with respect to product only. So what happened there with respect to product? What happened there? Product concentration increases. So plus value only. Product concentration increases. But what happens here, the whenever times is goes on, what happens there, the concentration of product is increased only. So what is the final product is the P2 minus P1 only. Change in the product delta P which is equal to P2 minus P1 only. Change in the time, how much is the change in time is T2 minus T1 only. So what happens there, the reference for rate of reaction is equal to increase in the concentration of product by time only. Increase the concentration reaction to the time. So delta P by delta T only. So just imagine some examples I am giving here, the how to represent a rate of a chemical reaction. So still remember here that the PCl5 breaks into the PCl3 plus Cl2 only. So what happens here, reactant concentration, this product concentration. So minus delta symbol is then large change in concentration, bracket is concentration unit term only, PCl5 by the delta T, that's the time only. What happens there, when times goes on, PCl5 concentration decreases only. When times goes on, what happens there, here the PCl5 concentration decreases, PCl3 and Cl2 concentration increases only. So that's mentioned plus symbols no need to mention very clearly. Delta PCl3 by delta T is equal to delta Cl2 by delta T only. Whenever you saw the product always containing a positive sign, reactant always containing a negative sign only. Suppose if they have given is then here all the coefficient value is 1, so no need to worry about this one. If coefficient value is different is then here 1 mole of nitrogen react with the 3 moles of hydrogen, it gives 2 moles of ammonia. So what happens for whenever you saw the coefficient value, you mention 1 by. What happens there, the 1 by 1 dN2 by dt, 1 by 3 dH2 by dt, 1 by 2 dNH delta NH3 by dt1, delta NH3 by dt1. So why the mention is 1 by 2 nothing but we are always calculate with respect to 1 mole only. But suppose here 1 mole of nitrogen is consumed here, 3 moles of hydrogen are consumed. Clear? 2 moles of ammonia is forming. That's the reason why the mention is 1 by 1 dN2 by dt minus 1 by 3 dH2 by dt, 1 by 2 dNH3 by dt only. Next one more thing is the mention is 5 Br minus BrO3 minus BrO minus 3, 6H plus is there, 3 Br to 3H2. I want to write the rate of chemical reaction. So first I have to take the 5 is there, 1 by 5 mention. First is reactant is there. Reactant always mention minus will come. Minus I am placing here the unit is 5 is there, 1 by 5 I have taken one. Delta Br minus by dt. Next one is there here also minus BrO3 minus by dt1. 1 by 1 only to mention only. So here the next one is done here is a reactant concentration only. So what I mean there is equal to minus 1 by 6 dH plus by dt only. These are all reactants only. So here next one is there here, consider the here, okay, product is there, product concentration is the 1 by 3 positive value, 1 by 3 dBr2 by dt. A product is water molecule is product, so 1 by 3 delta H2O by dt only. So whenever you saw the reactant, this reaction is there, the coefficient value 1 by you have mentioned. The coefficient value is 1 by 1. So these are the mathematical representation of a rate of a chemical reactions. Next one is then rate of chemical reactions classified into. You can find the rate of a chemical reaction by using of two methods. One is the instantaneous rate of a chemical reaction, average rate of a chemical reaction. What is instantaneous? Nothing but if you want to measure the speed, rate, velocity of a chemical reaction at particular time, fixed time, that's called instantaneous. Average rate of chemical reaction is large time intervals only. Large time intervals is average rate of a chemical reactions only. You can see here the average type of chemical reaction means just imagine here I started my journey from the Chennai to AP. I taken 10 hours time is there. So in this 10 hours time is there, maybe it will come very fastly or very slowly. It may be travel different velocities there. So average velocity means now will take the distance by the product time only. So instantaneous, what is instantaneous? But after 30 minutes, where I am there, what is my location? That is instantaneous only. So that is called instantaneous rate of chemical reactions only. We can say clear idea is then here average chemical reaction means from this point to this point on. Instantaneous means from the A to B where how much speed I have traveled, from B to D how much I am traveling, but instantaneous only. So you got very clear average speed of a chemical reaction, but overall change in the position by the overall time is taken only. Overall change in position by the overall time is taken only. For suppose from here to here how much time is taken, but here this is called average only. From the A to B how much time, B to C how much time, C to D how much time is, that's called instantaneous only. So remember how to represent average rate of chemical reaction, but average rate. look at with respect to concentration mention is there. C1 at the initial concentration. Look, this is C1. This is C2 only. So how can I mention is that here C2 minus C1 by time T2 minus T1 only. So when you saw the delta we are a large change in the concentration with respect to large change in the time only. This is called average rate of a chemical reaction. Average rate of a chemical reaction is a change in the concentration of a reactant and product measured at a definite time intervals only. Okay, no, definite time intervals, fixed time intervals only. We can say very clearly is a graphical representation only. I am taking the R0 nothing but initial concentration. So what happens the initial concentration slowly, what happens the reactant concentration slowly decreases only, slowly decrease with respect to time only. I have taken the time, I have taken the concentration is there. What happens whenever time is increases, the concentration of reactant decreases only. So this is the initial concentration, this is the final concentration. I want this nothing but here change in concentration is delta R. Because I measure the concentration at the T1 time. I measure concentration is R1. I measure the time is T2, the concentration is R2. I want to find the average speed. From this one is how much speed the reactant is consumes. So what I will take the delta R. What is delta R? Nothing but final minus initial only, R2 minus R1 only, delta T. What delta T change in temperature, time change in time is T2 minus T1 only. T2 minus T1 only. This is called average rate of chemical reactions. Average only. Next one is then here. One more thing is then here. Consider with respect to reactant dimension. This is with respect to reactant only. I want to mention with respect to product also. Look at it then here. The product is there. So what happens? Slowly the product concentration increases. So what happens? Initially at time T1 the product concentration is P1 only. At time T2 product concentration P2 only. It means whenever time increases, more product is formed only. Here more product is there. Change in the product concentration is a delta P. Here P1 P2 difference is called delta P only. T1 T2 difference is called delta T only. So what happens there are average chemical reaction but a change in the concentration of product delta P by delta T only. What delta P value? P2 minus P1 only, no? P2 minus P1 by T2 minus T1 with respect to time only. So rate of graphic representation chemical reaction with respect to reactant also mentioned, with respect to product also mentioned only. Next one is the instantaneous chemical reaction. Instantaneous means with a fixed time, a total time, how much my vehicle is moving, how much speed is moving. That's called instantaneous. Sorry. Look at it, consider that at this point is there, no, my vehicle is there, how much speed is moving. So it's called the instantaneous only. Instantaneous fixed time only. So what I mean then is consider the next one is the instant chemical reaction is there now. We can measure speed of chemical reaction each intervals only. From A to B, how much time, B to C, how much time, C to D, how much time, instantaneous. For finding of speed at one instantaneous, okay, that different time intervals called instantaneous chemical reaction. So when you got clear at some, if you want to get clear idea, look at this, instantaneous only. So what I mean, I'm taking reactant concentration. Reactant concentration slowly decreases or no. Look at I mentioned exactly this time, this point. I want to say this point, exact this point is there. Here what I mean there, how much the concentration of reactant decreases exact particular this time. This is called instantaneous only. So what I mean when you say the instantaneous chemical reaction is there now here, you will make one graph is there. You will make one line. A slope will make. When now the slope is touching this point is then this point I will take here. This is called delta T only. What is delta T instantaneous? Nothing but here the minus dr by dt only. Okay, instantaneous rate of chemical reaction is the rate of reaction at a specific interval time only. Instantaneous only. So how instantaneous chemical reaction you mention is then here the small dc by dt, not capital D, small dc by dt is called instantaneous chemical reaction. So, okay, no. Look what happens that when you saw the delta wave, so remember the mention clearly, when you saw the delta nothing but a large change in the concentration, D nothing but a small interval change in concentration. Okay, no. So what suppose I want to calculate the instantaneous rate of chemical reaction for the PCl5 decomposition only. So what I mentioned is minus dPCl5 by dt is equal to dPCl3 by dt dCl2 by dt only. So what I mean when you saw the D stands for is there no small interval of times only. When you saw the D is a small interval of times only. So students, up to I discuss about the what is the instantaneous rate of chemical reaction, average rate of the chemical reactions only. So next we will discuss about the factors affecting the chemical reaction.